Okay, it's time for some work on integration, which is the opposite process of differentiation. So integration is often referred to as anti-differentiation. Okay, now this is for the obvious reason that it works in the opposite direction. So if I've got y equals x squared plus 3, right, then I'll say that dy dx, which is the derivative of y with respect to x, is equal to 2x. Now hopefully you remember that. We did this a little while back. So going this way here, that's differentiation, or finding the derivative, differentiation. Right, and going back this way is called integration. So now we've got the derivative function equal to 2x. What's its integral? So differentiation finds the derivative, right? This is some language here, finds the derivative. So this is called the derivative. Integration finds the integral. So the integral is x squared plus 3, although as you'll find out as you do this, what this means is if I've got dy dx equals 2x and I want y, then what I need is y will be the integral of 2x with respect to x, and what we'll get is, we add 1 to the power, so we get 2x squared over, and we divide by the new power, and then we plus c because we're not sure what that is, so the 2's cancel, we get x squared plus c. Now that c in this case is 3, but because this drops on differentiation, that dissolves, doesn't it? It just becomes 2x, that goes. So we don't know what was there, so when we integrate we've got to allow for this plus c. Okay, so the general rule for integration is that for integrating x to the power of n with respect to x, the integral of that is equal to x to the n plus 1 over n plus 1 plus c. So let's make sure we've got that in place. That's how to integrate a polynomial. That's how it looks. So we get down to some examples and we have a look that way. So perhaps we have a look at the integral of 3x squared plus 4x cubed plus 3 with respect to x. And what we do is we say, righto, well that's each of these terms individually we'll look at. So 3x up the power by 1, divide by the new power. Go to the 4x cubed, 4x, 4 over 4. Go to the 3, 3x plus c on the end. And then we'll just do some simplifying. So the 4's cancel here, and the 3x stays, and the plus c sits on the end. Now, if we've got a question such as, so we've got an example here. It is known that the f dash x, which is the derivative function, is equal to this, and this bit here, this is going to help us. This will help us find c. But what we want f of x from f dash x. So what that means is, what that means is that f of x will equal to the integral of my f dash x, which is x cubed plus 4x squared with respect to x. Right? So my fx is the integral of this, because this is my f dash x. You understand? We go from f of x to f dash x. That's differentiation. But to go the other way, f dash x back to I should just use just use arrows. That way is differentiation, and this way is integration, f dash x to fx. So this is how we set it out. We go through now and we take each term, we add 1 to the power, divide by the new power, add 1 to the power, divide by the new power, put a plus c down. Righto, we've integrated, but now we're going to use this information here to find c. What this says is f of naught, remember this is f of x, Now f of naught equals naught. So f of naught, what that means is put naught in for x, and what we'll get, right, this has to equal 0. F of naught is naught to the power of 4 over 4 plus blah, blah, blah. So this is 0 plus 0 plus c. So therefore, from this we can find out that c equals 0. We can now drop that. So my f of x is equal to x to the 4 over 4 plus 4x cubed over 3 plus 0. I'm not going to write plus 0. I'm just going to leave it. Okay, so that's the end of solved the problem. I found f of x. So integrating, I've got a plus c, but now I had some information here to help me find out what that c was. Okay, one more example here, just before we get stuck into some questions of our own. Find y in terms of x if this is saying the derivative function dy dx is x squared plus 2x. Again, I'm going to go through just so that we understand y to dy dx, that way there is differentiation. If we're given dy dx as we are here, and we want to find out what y is in terms of x, or just get back to y, then we're integrating. So what we do is we get y will be equal to the integral of x squared plus 2x with respect to x. Okay, this business here, that is going to be my find c information. Okay, so let's just integrate firstly. X squared goes to x cubed over 3. 2x goes to 2x squared over 2. Notice that we just take that, add 1 to the power, divide by the new power. I'm going to put a plus c in there. I'm going to sort this out a little bit first. The 2's cancel here, so that just becomes x squared. Now y is equal to all that stuff, but I can find c by putting this information in here. So when y equals 1 when x is 1, y equals 1 when x is equal to 1. So x equals 1 over 3 plus x is equal to 1 here. 1 squared is 1 plus c. Okay, I've got some work to do. 1 is equal to 1 1/3 or 4/3 plus c. So c must be equal to minus 1/3. Does that make sense? 1 minus 4/3 or 4/3 minus 1/3 is 1. So therefore, y is equal to x cubed over 3 plus x squared minus 1 over 3. So you see the process now. We're integrating to get back to the original function, and then we're making a substitution from the information we're given in order to find c. Okay, plenty of questions for us in exercise 23A for us to have a go at, and that's what we'll use our next lesson for. I'll see you then.